All right. This is our science reading for week 9, day 2, sorry. And this is on biomimicry. So they're looking at nature and different ways that people have used that in the world to make advancements or to make things more accessible, like flight, looking at birds for flight, looking at a cat's eyes for reflective, even for safety. So there's lots of reasons why they do it. So this is called so there's the anti-reflective screens. Scientists have been studying insects for many years. In the 1960s, they discovered that the surface of a moth's eye, as well as that of a certain species of flies, reduces reflection. It took almost 40 years, but human technology finally developed to the point at which lasers could create screens that mimic the surface of a moth's eye. These new screens, which can often be found on computers, greatly reduce glare and make working and playing much easier on our eyes. I'm not gonna lie, moths creep me out because they flutter and they go all over the place and they kind of creep me out. But I'm glad to know that they helped create anti-reflective screens because that is very helpful. Self-cleaning paint in roof tiles. This is fascinating. The lotus leaf is pretty amazing. Okay, I'm learning a bunch of stuff right now because I don't know anything about a lotus leaf. Lotus plants grow in ponds and rivers where they can easily become covered with dirt and mud. No matter how dirty a lotus's leaf gets, however, a light sprinkling of rain completely cleans its surface. Huh. When water lands on the lotus leaf, its special surfaces cause the water to bead up and roll off. While the water is rolling off, it picks up all of the dirt and cleans the leaf. A group of scientists and engineers noticed this interesting feature and created paints of and roof tiles with surfaces that mimic the surface of a lotus leaf. As a result, every time it rains, the outside of houses with these paints and tiles are cleaned. What? Okay, that's pretty stinking cool. I'm glad I don't have to scrub the outside of my house. My house doesn't have that though. Mine's different. Oh, this is in that video, you guys. Check that video out. A kingfisher. A newly designed Shinkansen, I don't know how to say that, train pulls into Tokyo train station in 2010. Shinkansen train. Japanese Shinkansen train, also known as the bullet train, used to have a round nose, which worked great until it went into a tunnel. Because the train was moving at a speed of 210 kilometers per hour or 130 miles per hour, the pressure of the air around the train when it left the tunnel made a booming noise. That would be cool. To fix this problem, the designers of the train looked to the kingfisher, a small bird with a uniquely shaped beak and head that allows it to dive for fish without making a big splash. Oh. The designers based a new nose for the train on a kingfisher's beak. It not only solved the noise problem, but it also made the train faster and more efficient. What? It's cool. Swimsuits. Shark scales. It says a swimmer models one of the swimsuits designed to work like a shark's skin. Well, I don't know why would you want that. Let's see. Swimsuits. Sharks have been swimming in the ocean since before the time of the dinosaurs, so they're pretty well adapted to moving in water. One strong piece of evidence is their skin. It looks smooth, but if you were to run your hand over it, it would feel similar to sandpaper. That's because a shark's skin is actually made up of tiny grooved scales. The special shape of these scales help the shark move through the water easier and faster. At the 2000 Sydney Olympics, a number of companies showed off swimsuits that were designed to work like a shark's skin, and 80% of the swimmers who wore those suits won medals. What? Okay, that's pretty cool. I'm not a big swimmer, but that would be cool to know that you could go that much faster, that you could win a medal. I have to figure out which one of these I'm going to write about because these are pretty cool. Cooling systems. Oh, look at that. The Eastgate centray releases hot air through vents along the sides and tops of the buildings like a termite mound. What? I don't know about this. Cooling systems. Some species of termites build huge mounds in which to live. Biologists discovered that although the temperature outside might be very hot, the inside of the termite mound stays at a consistent cooler temperature. The termites keeps their mound cool with complex system of tunnels and vents that run from deep in the ground to the top of the mound. Because warmer air rises, the heat inside the mound escapes through the top, while cooler air comes up from below, keeping the mound at a constant temperature. The Eastgate Centray and Harare in Zimbabwe, totally massacred that just in case you wanted to know, was built with these same ideas in mind. It uses heat-resistant materials and special vents at the top to keep the large building cool, without air conditioning. What? Consequently, it uses only 10% of the energy that a normal building of the same size would use. Well, why aren't other people doing that? I wonder if it's just that much harder or there's other things that go into it. You would think that everybody would be doing that if you could save money. Huh. I wonder if you could find a way to do that in your house. Who knows? Interesting way to wonder. The Moss Landing power plant in California was one of the first to turn carbon dioxide into cement using a process similar to the one that corals use. Oh, that's a coral in the ocean. Building materials. You might have heard of carbon dioxide as one of the greenhouse gases that causes climate change. When we burn fossil fuels to create electricity to drive our cars, we put more carbon dioxide in the air. Some living things, like coral, actually use carbon dioxide to build structures. Scientists studied how these living things use carbon dioxide and then came up with a way to copy their process. It's now possible to take some of the carbon dioxide made by burning fossil fuels and create materials similar to concrete that we can use to build new things. What? Well, gee, golly, that you should just do that a ton. I wonder how hard that is, or expensive, because I'm assuming if it's pretty expensive, it's pretty hard for people to do, or get a hold of. Why is biomimicry so important? People are great at making things we want and need in many thousands that we want and need. In the many thousands of years that humans have existed, we have advanced from living in caves and hunting for food to sleeping in homes and shopping at stores. Our recent development has forced us to face some pretty tough challenges, and one of those is how we go about producing all of the things we use. To make the things we want and need, such as food, homes, plastic bottles, cars, and video games, just to name a few, we use great quantities of resources and produce large amounts of waste material and pollution. Often, the energy used to make and run these things comes from fossil fuels, which cause greenhouse gases to build up in the atmosphere. Also, we create many artificial chemicals that may harm the environment, while the things themselves often end up in landfills. When we're done using them. The buildup of the greenhouse gases, garbage, and other waste materials is starting to cause a problem for us. Our climate is changing because of pollution. We are running out of fossil fuels and other resources, and our garbage and our waste materials are contaminating the earth in a variety of ways. So, what should we do? I don't really know if I have an answer to that, but I'm going to think about it. Alright, so again, I can't find my science journal, so I'm just going to use this piece of paper and add it. Today is week 9, day 2, and we are talking about biomimicry. So I'm going to go back to the ones that I think were probably some of... I'm going to use the leaf one. I liked that one. The lotus leaf gave people, humans, an idea of how to make paint or tiles for houses that clean themselves, that clean off when it rains. Period. Number 2. The moth eyes one with the reflective, because anti-reflective screens are super helpful in like my computer right now is not reflecting all the light, it's not picking up everything, so I can sit there and see it. It's a huge deal now. Anti-reflective screens came from understanding how, what is it? Moths' eyes reflect less light. Number 3. I like the idea of studying animals slash species to find ways to make life better. 4. I wonder if they will be able to fix problems with trash and waste, like, garbage, by learning from life, like, like bio, like slash creatures. I don't really know how to quantify everything that would go under there. Number 5. They made a building that used 10% less energy by Mimicking a termite mound. That's a good thing. I don't know. I put left. Leaf. L-E. That's wrong. The lotus leaf gave humans the idea for how. See, I'm glad I looked that over. That wouldn't have made any sense. An M mark and a capital. +2. Capital. End mark. I like the idea of studying animals, such species, to find ways to make life better. I wonder if they will be able to fix problems with trash and waste by learning from life/creatures. I really hope so. They made a building that used 10% less energy by mimicking a termite mound. That's pretty crazy cool. I would like that. Because then you don't have to pay as much money.